So now we're going to do some practice with graphing rational functions. So here I have a rational function, and I'm going to first, before I do anything else, I'm going to look at the form. I notice that I have an x squared in the denominator, which means it's going to be in this form. Okay, it's one of these three columns on our chart. And again, this chart is posted in Canvas. It's in your weekly plan, and it is also posted in Canvas in the assignment. Okay. Sorry, my daughter's playing outside and I'm listening. It's a little distracting. Okay, so I'm going to look at this. And I know it's one of these three. And so now I'm going to pull out my A. My A is the leading coefficient, right, which is going to be 1. And the leading coefficient down here is 1. And there's a 1 there. I'm going to just make the invisible visible to help us out here. So my A is 1, my B is 1, my M is the degree here on top, and that's 1, and my N is the degree on the bottom, and that's 2. So from this, I see that M is less than N. So I'm going to look at that column on my chart. M is less than N. Okay, so then it says to find the x-intercepts, right? To find the x-intercepts, then I'm finding x where p of x, that's the numerator, equals 0. So I take, this is x-intercepts, and I'm going to take my 1x equals to 0. So x equals 0. That is my x-intercept. So I have an x-intercept at 0. Yeah, it's 0, 0. Because if this is 0, 0 divided by anything is 0. So then y is 0. All right. Then I'm going to find my y-intercepts. Or intercept. There can never be more than one. Okay. So if x is 0, y equals 0 divided by 0 minus 4. Again, that's going to be 0. So this point, in this case, is our x and our y-intercept. It's just one point. Then I'm going to find my vertical asymptote. And to do this, it says that I find x when q of x equals 0. So that's my denominator. So I'm going to say 0 equals x squared minus 4. And then I'm going to factor that. 0 equals x plus 2, x minus 2. So x equals negative 2 or positive 2. So I have two vertical asymptotes at negative 2 and positive 2. There's my information so far. And then my horizontal asymptote. So m is less than n, so our horizontal asymptote is automatically going to be y equals 0. Okay. Now notice on this chart, these are all the same. The only place that it's different is for the horizontal asymptote. That's where the process changes. Okay, so now I have found the key features of this, and from there I am going to type this into Desmos or my graphing calculator and find the graph. I can show you real fast on my graphing calculator. Okay. Divided by, make sure you're using parentheses on your graphing calculator. So that it graphs correctly. And then here's my graph. So I have a branch here. I have a branch here that's kind of this weird shape, and then I have a branch here. Okay. We can see that X and Y intercept right there at the origin. We can see my vertical asymptotes here and here at -2 and +2, and we can see the horizontal asymptote at 0. Okay, now to the next example. This one. Focusing. All right. So again, I've got these squared, so I know it's going to be one of these. And now I'm going to look. My A equals 1, my B equals 1, my M equals 2, and my N equals 2. Remember, M and N are the degree, and A and B are the leading coefficients. In this case, you don't see them, so they have to be 1. So M is equal to N. So I'm going to look on my chart, and I'm going to focus on this column right here where M is equal to N. All right. So first I find my x-intercepts. So I make my numerator equal to 0. X squared plus 1 equals 0. Okay, so there is no value for x that could make this true, because anything we put in for x we're going to square, and a positive plus a positive can never equal 0. So no x-intercepts. All right. Y-intercepts. We substitute 0 in for x. So y equals 0 squared plus 1 divided by 0 squared plus 4 times 0 plus 3. So these are just 0, so it equals 1/3. So I have a y-intercept at 0, 1/3. All right, and then my vertical asymptote is where the denominator equals 0. So 0 equals x squared. Remember, that's always going to be the case because we can't divide by 0. So that's where that comes from. This is a 3. Okay, so if I factor this, thinking about our diamond, I need two numbers that multiply to make 3 and add to make 4, so that's going to be 1 and 3. 1 times 3 is 3, 1 plus 3 is 4. Okay, so then x equals -1 and -3. And then my horizontal asymptotes. Okay, I'll go back to here. Y equals A over B. So my A was 1, my B was 1. Sorry, I was way off the screen there for a second. So my horizontal asymptote is y equals A over B, which is 1 over 1, which is 1. So y equals 1 is my horizontal asymptote. Okay. Yeah. And then again, we can put this into our graphing technology and see what the graph looks like. So x squared plus 1 divided by x squared plus 4x plus 3. And alright, so that one is super weird. It's got this branch here, and then it's got this weird almost upside down parabola shape, and it's got another branch over here that's kind of bent a little bit. It's not symmetrical to this one. So very strange, but cool at the same time. All right. So then let's look at this one. Okay, so for this example, I don't know why this faded so much. All right, my A equals 1, my B equals 1, my M equals 2, and my N equals 1, right? There's that invisible degree of 1 here. So M is greater than N. Again, I see that x squared, so I know we're in polynomial land over here. And my M is greater than my N, so we have this column right here. So I'm going to go through the steps. Now the first 3 steps are exactly the same. So I have my x-intercepts where the numerator equals 0. So x squared plus 2x minus 3 equals 0. I'm going to do my diamond off to the side here. So 2 numbers that multiply to make -3 and add to make +2 would be +3 and -1. 3 times -1 is -3. 3 plus -1 is 2. So this is x plus 3, x minus 1 equals 0. So x equals -3 and +1. Those are my x-intercepts, or I could write that -3, 0, and 1, 0. Those are my 2 points. All right, then I need my y-intercepts. So here I'm going to have y equals 0 squared plus 2 times 0 minus 3 divided by 0 plus 2. So remember, y-intercept, I'm just substituting 0 for all the x's. And the zeros are gone, so that just leaves you with -3 halves. Okay, so 0, -3 halves is a point on my graph. And then I need my vertical asymptote. Well, this is always where the denominator equals 0, because we're not allowed to divide by 0. It's undefined. So x equals -2. And then my horizontal asymptote. All right, and this is where people are losing their minds. There is no horizontal asymptote. Great. None. And then it says end behavior is the same as y equals a divided by b times x to the m minus n. This is the only time that we look at end behavior. This is it. Only one. All right. So end behavior. Is the same as y equals a over b is 1 over 1 times x to the m minus n is 2 minus 1. So this is 1, this is 1, so it's the same as y equals x. Well, y equals x is a line like this. And as x gets more negative, y gets more negative, and as x gets more positive, y gets more positive. So I would describe the end behavior. Y approaches negative infinity as x approaches negative infinity, and y approaches positive infinity as x approaches positive infinity. Let me try to adjust this a little. There we go. Okay, so now we have that information. Again, this is the only scenario where you have to look at end behavior. People are looking at end behavior for everything. This formula doesn't even necessarily work for the other ones. We're not going to use it. So now I'm going to use my graphing technology. The reason we're finding all of this by hand is for a lot of reasons. Later in pre-calculus, it's going to help you find limits. It helps to make sure there's a lot of different places that you could type in this wrong to the graphing calculator. So you want to have this information so that when you type in your graph, you can look at your graph and make sure, yes, in fact, I did do this correctly. We never want to trust our technology to think for us. We need to be smarter than our tools. Okay, so now I've typed in my equation and I hit graph. Okay, so you can see right here we're approaching our vertical asymptote of -2 from both sides, but out here we're going off into infinity, positive infinity, and out here we're going off into positive or negative infinity. So these two ends are what we're talking about with the end behavior. These are approaching the asymptote. These are our end behavior, each approaching infinity. All right.